Hello everyone. Let's start with the presentation of artificial intelligence as a service. This is the agenda for the presentation. I will start with an introduction and project overview, following with the technologies and tools and system architecture. I will explain in detail my testing strategy and evaluation results. After that, I will continue with the system demonstration, which basically I will showcase the implemented solution. Next, I will have the opportunity to walk through the code, and to finalize, we'll have the Q&A and the showcase poster. So let me introduce myself, please. My name is Maximiliano Herrera, and my student number is 2010-3212. I am on my last year of bachelor in computing with specialization in software development. The project that I have been working in is artificial intelligence as a service, and on the next slide, I will explain in detail more about the implemented solution. So, what is it? Artificial intelligence as a service is a cloud-based platform that provides seamless artificial intelligence services for enterprise applications. Its user-friendly interface simplifies dataset import, machine learning model generation, and model deployment. Who is it for? This product is not intended to be used by a regular user. It is intended for enterprise applications. By enterprise applications, I mean applications or systems that operate in a corporate environment. So what does it do? It tries to make it easy to work with machine learning without the need of coding. Normally, in a typical machine learning workflow or pipeline, there are some common tasks such as ingest data, clean and fill missing values, normalize, model training and evaluation, and finally, there is the model deployment. My solution takes a graphical approach and facilitates the deployment process, allowing users to consume a machine learning model and make predictions from an endpoint. How is it different to existing solutions? Comparing with some of the existing products on the market, my solution is quite different because it is not coupled to cloud provider resources. For example, in Azure Machine Learning, to create a machine learning model, first, the user must create many cloud resources such as workspace, storage accounts, keyboards, app insights, container register, and cloud computing environment. In this solution, there is no code involved from the user perspective, so he doesn't need to know about Python or C# or any language. It is more like a software as a service rather than platform as a service. And also this solution takes a full graphical approach. Okay, so now let's talk about the technologies and tools that I used on this project. Let's start with the backend technologies. Well, on the backend, we have C#.NET 6, ML.NET, which is machine learning for .NET, Signalor WebSockets, Entity Framework with specifications pattern, SQL Server database, Docker containers, and CQRS mediator implementation. On the front end, we have Angular 15 with, of course, HTML, CSS, JavaScript, TypeScript. I incorporated ngRx, which is a state management for Angular, Angular Material, Kendo, and ngFlow charts, which is the library that I am using to visualize the workflow. As a cloud technologies, we have AWS, EC2, or RDS, SQL Server, CloudWatch for logs and metrics, Heroku, Auth0, CI, and GitHub. Before going further, I would like to highlight the differences between a machine learning pipeline defined on scikit-learn Python and ML.NET C#, which is machine learning for .NET. Okay. So on the left-hand side, I have defined a very easy and simple pipeline for, using scikit-learn Python. So there are 4 steps: load, training, prediction, or predict. I didn't up the cleaning missing values or normalize because I would like to keep it simple. So on the first step, the load, basically with Panda you load the datasets, and Panda make it quite easy. You don't need to define any type, you just load it. In the training step with linear regression, you train the model. The predictions, as well, you call predict from regression using the feature from the test set, and you retrieve the targets. That is because you need to evaluate the model at some point. The next step is to predict only one target from a set of input or targets. It's quite easy as well in Python. Okay, now on the right hand side, we will do the same with ML.NET C#. As you may know, that C# or JavaScript, or Java, is a strongly typed language and statically and strongly typed language. So that means that all the types need to be defined before the build time. So you need basically you need a class for every type before you start to build your solution. Okay, so now to do the same thing to load a dataset, using here we call the load from text file, and we pass in a generic method a class, which is a type, a taxi tree. This taxi tree basically has properties that match with every column on the dataset. So that's a problem, because with this approach, you need to define a class for every dataset you would like to load. The next step is just training the model. It's quite straightforward. To retrieve the prediction as well is easy. But the next step, which is score or predict, is not so easy as it seems, or as it is on Python. So basically, you have to create a prediction engine. And to create a prediction engine, you need an input class and an output class. And after that, with the model, you can send your input, which is the instance of taxi trip in this case, that define a set of features. So to the prediction engine, you send that instance and you get the prediction. So as you can see, this is you need the types. So I wouldn't like to follow that approach. What I wanted to do is something more dynamic. So if I want to load new data set, I don't need a class. To achieve that, I needed metaprogramming from .NET that allow you to create in runtime C# classes or C# types more correctly. So now let's continue with the architecture. On this slide, I would like to introduce the system architecture for artificial intelligence as a service. On the screen, you will be able to see there are 3 components: Auth0, Heroku, and Amazon Web Services. Auth0 is used as identity and access management. So that means the solution delegates into Auth0 authentication and authorization. I am using a ShareWT token that I request from Auth0. I request a token, and I in every request from my website, I send to the backend that token with claims. The claim has a role and other user information that I use in the web API to grant or deny the access, right? So from my solution point of view, I have two nodes run. One runs in Heroku, the other in Amazon Web Service. On Heroku, I have a single page application, which is developed in Angular. I have chosen Heroku because it provides HTTPS. They already give you the certificates and nice domain, so and also the auto deploys accelerate the deployment process. So basically, when I push to GitHub repository, automatically get deployed into Heroku. So this is one of the features that I was looking for to accelerate my process of development. On Amazon Web Services, we have complex architecture, I will say. Basically, we have an EC2 where there is running a web server NGX. NGX, there is a web API that is running on a container, Docker container. And the web API is developed in .NET C#, which is my backend. In the web API has two sub-components, signal-or for WebSockets and prediction endpoint. Signal-or because what I wanted to do is improve the communication between the website and the web API, and to give in real time updates to the user. Okay. The prediction endpoints provides basically access to the model, so the customer can request prediction services to that through that endpoint. And in the endpoint, basically what I do is to retrieve the generated machine learning model and generate a prediction in base of the input from the client. Okay. Okay. We talk about the EC2 now. On the Amazon services environment, we have other components. We have AWS S3, CloudWatch, and RDS SQL Server. Okay, AWS RDS SQL Server is my main database instance. There is a secure channel between the EC2 and the RDS SQL Server. Both are using HTTPS, and only the EC2 is allowed to access to the DB instance. So there is a good level of security in relation to the database storage. I am using also AWS CloudWatch, which provides real-time logs and metrics. That is fundamental to understand what is going on behind the scenes and under the hood, let's say. So if there is a problem, I have real-time logs. I can check where is coming the error, and also the metrics indicates if I have a peak on the processing of the EC2 or if the EC2 is down. And lastly, I have AWS S3, which I use as a storage. What I am storing in that EC3 is dataset files and data view storage. What is a dataset file? Well, When the user wants to create a dataset, basically the user uploads a file. That file, rather than being stored in the database, is being stored in S3. That provides high performance and allow the architecture to scale and to handle large files of datasets. Data view storage this is intermediate binary data. This is about to store transformations applied to the datasets. As I will show in a later stage, our machine learning workflow is composed by operators. Each operator applies a transformation, for example, clean, normalize, train. So I am storing in S3 all those transformations. So this way the user will be able to view or preview the result of a given transformation. That's the reason of storing the intermediate binary data. As a client, we have two clients, administrator and artificial intelligence consumer or endpoint consumer. Administrator basically what he can do is to manage the system, create datasets, create machine learning workflows, generate machine learning models, create endpoints, view the model metrics, so on and so forth. The endpoint consumer, this customer can request a prediction or recommendation to the artificial intelligence service via endpoints. So, for example, if you want to get price prediction or binary classification, he can send an input, which is known as features, and he will get a result, a prediction. Okay, let's continue with the next slide. So on this slide, we'll talk about testing. Well, let's talk about my testing strategy. Given the technological complexity of this solution, which include machine learning for .NET, Angular, SQL Server, AWS, or file storage, I have decided to go for a manual testing strategy rather than automated. And to ensure a proper testing, I have created a comprehensive test plan that covers different aspects of the solution, covering end-to-end functionality, including non-functional requirements, such as security and performance. So my scope, as I said before, is a manual testing of the solution implemented. And the environment is the production environment where I have deployed my product. My objective is to verify and validate functional and non-functional requirements, including performance and security concerns. My strategy is to run functional testing, regression testing, and non-functional testing, as I commented before. These are my test cases, and I have run all of them, and all of them were successfully passed. It is worth to mention that while running the test cases, I found issues, and those issues were fixed and deployed into production environment. And after that, I ran the regression testing to ensure that the system behaves as expected. Evaluation. The evaluations of the implemented solution primarily focus on three key factors: user friendliness, accuracy, and performance. For this evaluation analysis, it was utilized well-known datasets. They are described in this table. As you can see, most of them are small, except credit card, which is almost 150 megabytes. What I did is, in order to compare, I have created identical machine learning workflows or pipeline for each dataset. One of them machine learning workflow was implemented with my solution. The other was implemented with a Jupyter notebook using scikit-learn. As you can see, there are in these tables, I highlighted in green when my solution outperformed scikit-learn. No? So we have method comparison, performance, and the ability to predict. So through the evolution of user-friendliness, correctness, accuracy, and performance, the implemented solution demonstrated that can provide significant advantages compared to the traditional approach. It was able to deliver comparable accuracy and prediction capabilities. Even on performance terms, the solution has shown a great potential, and it has completely exceeded my own expectation, which I had defined on the initial non-functional requirements related to performance. In relation to performance, scikit-learn provide better results, but in a large data set, we can see that my solution outperformed scikit-learn. That's amazing. So I was very surprised about that. But Microsoft state that, in fact, machine learning for .NET performs better than scikit-learn for large data sets. So now let's continue with the demonstration. So let me introduce the product. This is Artificial Intelligence as a Service. This is the landing page. As you can see, there is an explanation for each entity, dataset, workflow, model, and endpoints, as well as a brief description of what should be the workflow of the application. No? Input dataset, create workflow, generate machine learning model, and deploy the model. Okay. So let's start with the to create a dataset. Okay. Select the file. One second, so that. Select the file. We have a preview in here. Just continue. We can change this schema here, but we will not change anything. So this is created today. So let's. So I did a mistake, so I'm gonna remove it. Let's start. Sorry about that. Because I already have one in the system, so I want to identify the new one. Okay. So I'm gonna create a workflow, but rather than creating from scratch, I will use a template that will allow me to quickly create a data set. This is the one I created. Select all, normalize. I'm gonna select all except my targets. These are parameters from machine learning. This is splits, the percentage of tests, that's fine. And this is this is my targets. I'm gonna select regression. And I will choose the first one, okay? So I can visualize the data set in here. I will click in run. Finish. So now I can visualize the metrics. I have some metrics. I also have a history. And I can click to visualize how long it took for every node, okay? So let's come back. It's worth to mention that there are some updates, as you can see, that occurs in real time. That's because we have WebSocket implemented, okay? Now I have the model, I will publish. And I will rename this one just to make it clear, okay? So now I go to the model, the endpoints, and I can see my endpoint created here. I have some basic information, and I can test it. This is like just a sample, no? But basically I can use the prediction endpoint here. And also I have the URL where I could use, this is Postman. No, I have this body. If I send this to the server, I get a prediction, 21, okay? And in the UI, I could use the same prediction and I get the same value, okay? So that's the whole workflow. I already created many workflow in here. For example, credit card, I can visualize. This is a heavy one, it's 150 megabytes. And I have the taxi fare full and run it. Do you see there is a real-time interaction that is coming from the WebSocket, okay? Yeah. It's taking more time than expected. Yeah, okay, that's completed. One more thing, this is my solution. I have linked my solution to CloudWatch, so I can view metrics and the logs. And you can see there are logs in here. So in real time, I can visualize all the logs. Okay. I can see also this is the S3 production environment, so the bucket, and I can see there are files being created. So that's working. Okay. So that's all. Now I would like to go through the code. So we have the web API, the controllers. This is the starting point, workflow controller. So every time I run a workflow, I am going to the controller, which dispatch a command, which because this is following CQRS. Also, I run the workflow in here in the handler. And also I am attaching to events because as I commented before, I am sending to WebSocket to notify the UI. So if I go to the run processor, So the important thing is here where I have for each for every node, every workflow. I send notifications before and after the process node. And here the processing of the node. There are basic operations, pre-processing, hide data states, propagate data sets, and validations. And after that, I run the workflow, the node. This is implemented in here, features, workflow, nodes. As you can see on the right-hand side, there are many operators already implemented. Clean, dataset, edit, evaluate, normalize, split, train, and an abstract. So that's all from the implementation side. So now let's continue with the question and answer questions. Let's start with the first one. Discuss the most difficult aspect of your project. The most challenging aspect of my project to be completed was the generation of a machine learning model from a workflow definition. The difficult part comes from the characteristic of the language C# because it's static typed. And so in order to build a consumer machine learning model with C#, I am using ML.NET. And because C# is a static typed language, for some operations, as I showed before, such as reading from a dataset or generated a prediction, requires to pass a parameter as type, or in some cases, an instance of a type. And that's very complicated because basically you have to generate on runtime classes. So that means you need to use metaprogramming reflection to generate on runtime classes. So that part was very difficult to do it, but I was able to do it. Second, discuss the most innovative aspect of your project. Well, the most innovative aspect of my project was to use ML.NET library. This is machine learning for .NET. Usually the people use scikit-learn with Python when using machine learning, but nowadays there are a lot of companies that they are looking to move to .NET, or they already have their architecture using .NET. So for them, it's easy to implement machine learning using the same technology. And I know by first hand that many teams are researching on this technology. So for me, it was very useful to have the opportunity to use it and get experience on it. With respect of your requirement specification, what requirements have you added or removed or changed it? Well, I didn't remove any of the requirements. I added more. For example, to manage large files, I use AWS S3. Also, for the logs and metrics, I am using CloudWatch, so that was added. The skill in detail your approach to testing. My approach to testing, as I commented before, is a manual approach. I focus on the functional requirements and covering as well the non-functional requirements such as security and performance. If you were to start your project again, will you change any of the decisions you made? Well, one of the decisions that to change was and is a little bit limited. So to implement complex workflows, I think I will need another library. Yeah. So Now, this is my poster. And the poster, you can see there is the bio section. We have the technology for the, no, sorry, the technology for the backend and frontend are in here. And in the second part is a description of the product, which is a cloud-based platform that provides seamless AI services for enterprise application. So thank you for your time, and especially I would like to thanks to Enda and Francis for your help during my journey. Thank you so much, guys. I hope you like it. Thank you.